So continue the lecture, and here we have a problem with data on it. So you have a man measures his heart rate before using a treadmill and after walking on a treadmill. So now you know that it's a longitudinal study, and for 10 minutes on 7 separate days. So he counts his mean heart rate at baseline and 10 minutes after walking is 85 and 93. So this value is the DI, so the difference. So this is the baseline value and this is the follow-up value. So D bar becomes the baseline minus follow-up, so 85 minus 93. Now the mean change from baseline, they have given the data already, so you don't need to calculate this D bar. So the mean change from baseline to 10 minutes is 8 BVM. So this is D bar, and the standard deviation is 6 BVM. So this is SD. And because he has taken it on 7 separate days, so he will have 7 different measurements. So N becomes 7. So now use this data and calculate the p-value. And they're also asking you for a 90% confidence interval. So to find the confidence interval, so the formula is D bar plus or minus the Z value, so the T value, T1 minus alpha by 2 into SD by root n. So this is the formula for confidence interval. So here it's a 90% confidence interval. So alpha becomes 0.1. So find T1 minus alpha by 2. So which is T1 minus 0.05. So that's basically T0.95 at DF equal to N minus 1. So N is 7. So it becomes 6. So find T0.95 at N equal to 6. So at DF equal to 6. And substitute it into the formula and find the confidence interval. So that's the problem for 90% confidence interval. And finally conclude with the p-value. What is the significance level? So use the significance level and conclude about the data. So pause the video right here and try to solve this problem. So in the next part, let's continue 2-sample t-test. Here for independent samples with equal variance. So the idea here is that 2-sample t-test for independent samples. So we know that independent samples are only used in cross-sectional studies. So this test goes specifically towards cross-sectional study. So what do we do here in a 2-sample t-test? So we have 2 different samples. You have x1 bar and x2 bar. You have n1 and n2. So and each of these values you also have s1 and s2. So here we are doing a 2-sample t-test, right, with equal variance. So in this case, so this is the sample 1 data and this is the sample 2 data. So you have sample 1 data and sample 2 data. So using sample 1 and sample 2 data, now what can we do? You have to find the t-value. So t-value becomes x1 bar minus x2 bar by s into under root 1 by n1 plus 1 by n2. How do you find this s value? So s value becomes n1 minus 1. So we have to find s square here. So s square becomes n1 minus 1 into s1 square plus n2 minus 1 into s2 square divided by n1 plus n2 minus 2. So if this looks similar, this is the same formula that we used in sampling distribution when we were calculating the difference between two means. So you can go back and review that if you want to understand it better. So here we are going to find S square value. So if you want to find S value, basically square root this value. So this will become your final value to find S, and calculate the T value, and the rest of the method stays the same. So you have a distribution. So, and you have two stopping points. And you have the acceptance region, and you have the rejection region. So this value is minus t minus 1 minus alpha by 2. This value is t1 minus alpha by 2. So this is when we do the critical value method. So critical value method, again I'm going to remind you, this is only when, so we need alpha to calculate, we need alpha to do the critical value method. So if the t-test value lies between t minus t1 minus alpha by 2 and t1 minus alpha by 2, so which is basically in this region, so then we accept H0. If the t value is either in this region or in this region, so then we reject H0. What is H0 and what is H1 here? So H0 considers that there is no difference between sample 1 and sample 2. H1 considers that there is a significant difference between sample 1 and sample, so that is H0 and H1. So this is the critical value method. So in terms of the p-value method, it stays the same. So the formula for p becomes 2 times the probability of t(n minus 1) less than t if t is greater than t is less than 0, and p becomes 2 times 1 minus, so 1 minus the probability of t(n minus 1) greater than t. So when t is less than 0. So you don't need to use this formula every time. So you can use the simpler method and check where the t value lies between the probabilities and take it as p by 2. So what are the two values it lies between, and calculate the p value where it lies between from the table. Once you calculate that, then you can comment on the significance level. So the significance level, again you will use the same table between 0.01 to 0.05, 0.001 to 0.01, and less than 0.001. So statistically significant, highly significant, very highly significant. So we use the same table again to calculate the significance level. Now, so let's do this problem and see if we can calculate the values that we have. So let's write down the data what they have given. So suppose a sample of 8 35 to 13-year-old non-pregnant premenopausal OC users who work in a company have a mean systolic blood pressure of 132.86 with a standard deviation 15.34. So this is sample 1. So N1 is 8, X1 bar is 132.86, and S1 is 15.34. So that is in terms of, just a second, sorry. Now in sample 2. In sample 2, so you have 21 non-pregnant, premenopausal, non-OC users who have systolic blood pressure of 174.44 and a standard deviation of 18.23. So N2 is 21, X1 bar is 127.44 and S2 is 18.23. So these are the values that we have. So let me copy those values. And let's use those values. So now we have the values. Now let's calculate first the S value. So S value is square root of N1 minus 1 into S1 square plus N2 minus 1 into S2 square by N1 plus N2 minus 2. So that becomes square root of 8 minus 1 into 15.34 square plus 21 minus 1 into 18.23 square divided by 8 plus 21 minus 2. So let's find the value. So you have square root of 8 minus 1 times so this becomes under root 7 times 15.34 square plus 20 times 18.23 square divided by 27. So the value becomes under root. So if you calculate it, you get 8293.9 divided by 27. So which becomes 307.18 under root. Now if you take S value, it becomes 17.527. So you can calculate it. You can pause here and calculate it using a calculator. So this S value is called the pooled estimate of variance. It's called the pooled estimate of variance. Now we have the S value, we have everything that we need. So now calculate the T value. So T value becomes x1 bar minus x2 bar divided by S into under root 1 by n1 plus 1 by n2. So that becomes S1 bar is 132.86 minus 127.44 divided by 17.527 under root 1 by 8 plus 1 by 21. So now if you calculate the value, you get 5.42 divided by 17.527 into 0.415. So that gives you a value of 5.42 divided by 7.282. So the final value you have is 0.7. So the T value that you get is 0.7. Now you have the T value. Now we want to calculate the P value. So So we want to see where 0.27 lies. Now we have to find the df. So df is n1 plus n2 minus 2. So you have 21 plus 8 minus 2, so which is 27. So we are looking at df equal to 27. So we have at df equal to 27. So this is the value 27. And we want to look where 0.74 lies. So it lies between these two. Now, what are those values? So the two values. So use the one tail to determine the value. So it's 0.25 and 0.20. So let me write down the two values. 0.684 and 0.855. So for 0.855 the value is 0.20. For 0.684 the value is 0.25. So this value is p by 2. So p value now lies between 0.4 and 0.5. So now this is the value where the p value lies. So now once we have the p-value, what can we do? So notice the p-value here lies between 0.4 and 0.5, which means that the p-value is greater than 0.05. So now we can say that there is not, so it's not statistically significant. Right? Don't forget that this is 0.5 and the value cutoff is 0.05. Right? Now this is not statistically significant difference. So here it's not statistically significant difference. So the statistically significant difference here we are talking about in an office, people who take oral contraceptive and non-oral contraceptive. So this is sample 1 and this is sample 2. So even though the data looks as if that the blood pressure is a little higher, so the test determined that there is no statistically significant difference between OC and non-users. So there is no statistical significant difference in the systolic blood pressure between OC and non-OC users. So this is H0. So remember that here we considered that we have two hypotheses, H0 and H1. So H0 is that it says that there is no difference in systolic blood pressure between OC and non-OC users. H1 says that there is a significant difference in systolic blood pressure between OC and non-OC users. So because the p-value that we have is greater than 0.05, so we say that we accept H0. So there is no statistical difference between the OC and non-OC users. So that's our understanding of the data. So now try this problem. So here you have a systolic blood pressure of 81.9. So this becomes x1 bar, x2 bar, this is s1, s2, this is n1 and n2. So use this data and find if there is any significant difference. Now, if the question asks for a confidence interval, what will be the formula? So here the formula is x1 bar minus x2 bar plus or minus. Here we're going to use t 1 minus alpha by 2 into s into under root 1 by n1 plus 1 by n2. Again, the formula for s does not change, so which is under root n1 minus 1 into s1 square plus n2 minus 1 into s2 square divided by n1 plus n2 minus 2. So this is the formula for confidence interval. So for example, if it asks for a 95% confidence interval, you have an alpha of 0.05. So the t-value that you find is going to be at t 0.975 and at tf of n minus 2. So df here is not n minus 1, it's n1 plus n2 minus 2. So this is the formula to find confidence interval when you have a two-sample t-test with equal variance. So that ends the topic of two-sample t-test with equal variance.